Okay, so now we are in topic 2, section 2, day 2. And so we're going to start with example 2. So in the previous video, we did example 1 in the first try it problem. So now we're going to jump to example 2. And it says, how can you use the key features to graph this function right here? So again, we have our steps listed out for us. And step 1, find the vertex and the axis of symmetry of the quadratic function. So from our previous notes, we learned to find the vertex, we need to first do x equals negative b over 2a. So let's go ahead and just identify what a is. And so a would be 1. B is negative 4. And then C is 8. So we're going to plug these in. So we have negative B, which is negative 4, over 2 times A, which is 1. And so that gives us a positive 4 over 2, which equals 2. So for our vertex so far, we have 2, comma, and then we need to find our y value by plugging this in. So we're going to have 2 squared minus 4 times 2 plus 8, which that is going to be 4 minus 8 plus 8. And then that would equal 4. So this gave us this part, and then this is giving us this next part here. So that's the vertex. And then it said to identify the axis of symmetry as well. And the axis of symmetry, we had said, was the x value of this. So axis of symmetry equals x equals 2. So x equals 2 right here. That's our axis of symmetry. And then our vertex is at 2, 4. Okay. Step 2, find the y-intercept of the coordinate of the function. So again, remember our c value is our y-intercept. So our y-intercept is 0, comma c, which in this case would be 0, 8. And my graph doesn't go to 8, so I'm actually going to redo this where this is counting by 2s. So this would be 2, 4, 6, 8, 10, 12, 14. So again, I'm just going to count by 2s on my y-axis. So my vertex would be 2, 4 right here. And then my y-intercept is at 0, 8, so right here. And then find a point symmetric to the y-intercept across the axis of symmetry. So here's the axis of symmetry. This is 2 away, so the other point on the other side would be 2 away on the same level. And then you can sketch the graph from that. So we found the vertex, we found the axis of symmetry, we found the y-intercept, and then just one that would be reflected over that axis of symmetry. So now I would like you to go ahead and pause the video and try doing the try it problem. So I started off by identifying what A, B, and C are. And then I found my vertex by doing the negative b over 2a. And so my x value became 3. And again, that's also my axis of symmetry. So x equals 3 is my axis of symmetry, and it's my x value, my vertex. Then I plugged 3 in. So again, this was right here. And then I plugged 3 in to get my K value, or my Y value of my vertex, and that was -10. I have my axis of symmetry, again from right here, and then my y-intercept is going to be my C value, which was -1. So now I'm ready to graph this. Again, my vertex is -10, so I need to count by 2's again. So again, this is going to be -2, -4, -6, and so on. And so my vertex would be 3, -10. So right here. And then that's also where my axis of symmetry is going through. That's where I can cut my parabola, my U shape, in half. And then I have my y-intercept of 0, -1, so right here. And then that would be the same on this side here. And then you just draw your U shape. Okay, so now we're going to go to the next example. And we have the graph of the function f of x equals -10x plus 700x minus 6,000 shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can earn? So the maximum would be the vertex. So the max would be the vertex. So we need to find the vertex, this point right here. And so if x is the selling price and y is the profit, we need the y part of the vertex. So we need the k part for the max prof. So we're going to find the vertex, which we said we need to do x equals -b over 2a is the first step in finding our vertex. So we need to identify a, b, and c. So a is -10, b is 700, and c is -6,000. So we're going to plug these in now. So we have -b over 2a. So b is 700. A is -10. And then we're going to simplify this. So we did -700 over -20, which equals 35. And now I need to plug this back in to this function here. So I'm going to plug it back in. So I'm going to have -10 times 35 squared plus 700 times that 35 minus 6,000. And you can plug this into your calculator. And when you plug it into your calculator, you get 6,250. So the final answer is the company can make a max profit of $6,250 if they sell the items, so headphones, for $35. Okay, so this is your final answer. So again, the company can make a max profit of this if they sell the headphones for this price. Go ahead and pause the video and try the next two. and then check your answers at the end. Okay, so I did first the negative b over 2a, and b is 160, a is negative 16, and then I got negative 160 over negative 32, which is 5. So that's the x value of my vertex, so that would give me the time that it reaches the maximum height, but I want to know the actual maximum height as well. So I'm going to plug 5 in to this equation up here. So we have negative 16 times 5 squared plus 160 times 5 plus 50. And we put that in our calculator or simplify it and we get 450. So the max height of the balloon is 450 feet at 5 seconds. And then for the next problem, it's the very similar process. So now we're talking about a pebble and we want to know what the maximum height is and when it reaches the maximum height. So again, we are doing the negative b over 2a, and b is 32, a is negative 16, which gives us negative 32 over negative 32, which is 1. So it's going to reach the maximum height at 1 second. And then to find the actual height, we're going to plug in 1. So we have negative 16 times 1 squared plus 32 times 1 plus 80. And when we simplify that, we get 96. So the pebble reaches its maximum height of 96 feet at 1 second. Awesome. So that is the end of topic 2, section 2. And so we will be next talking about section 3 in the next pre-recorded video. Thanks anyone that watched, and I hope these videos are helpful.